Hi, I want to talk to you today about a very important mathematic concept in APES, which is called dimensional analysis. And you've done this in chemistry before, I'm sure. But just so you know, there's only about three mathematic techniques that you need to apply in APES. The math is pretty straightforward, but this is a big one. You'll be asked this quite a bit on the AP test, so let's just go ahead and get started. So the idea is to use dimensional analysis, that you have to know a certain number of conversion factors. And you'll usually be given these, although there's some you need to memorize. I'll talk about that in a minute. But basically, if we're told 1 pound equals 16 ounces, or 1 pound equals 0.45 kilograms, or 7 grams equals 1 milliliter, if I have a conversion, a statement of equivalency, then I can proceed to use dimensional analysis to convert from one unit to another, which is a technique they often want you to demonstrate on the APES test. So I will say there are certain things you need to memorize. And so not a lot, but these ones here, and hopefully you've already memorized these. So you do need to know that the prefix kilo refers to 1,000 of the base units. So a kilogram is 1,000 grams, a kilometer is 1,000 meters, and so on. You need to know that centi is a prefix. It says Senate instead of centi. Sorry about that. You need to know that it means 100. So if I have a centimeter, it means 100 centimeters equals 1 meter. 100 centiliters equals 1 liter, and so on. And you also need to know that 1,000 millis equals one of the units, one of the base units. So 1,000 milliliters equals a liter, 1,000 milligrams equals a gram, and so on. You need to know those three prefixes and the corresponding equivalency statements or conversion factors that they represent. So please just make sure, if you haven't memorized this yet, I don't know what you've been waiting for, but now's the time to memorize it. Okay, so here's what we do. Conversion factors allow us to change from one, or to convert from one measurement to another, while keeping the overall value of what we're measuring constant. All right, so let's just say I want to convert 25 ounces to grams. So here's what I do. First of all, I write down the unit that I want to convert, and I have to include the unit. So you can't be lazy with this. And on a FRQ, they'll take off points if you are lazy with this. You must write down the units. They're like the street sign that are going to guide you to the correct answer. So in this case, I want to convert 20, I want to get rid of ounces, I want to end up in grams, but I still want it to be the same amount of matter, right? So I write 25 and I write ounces. Now, the next thing is the most important part. I'm going to multiply uh, by a fraction. And the top of this fraction is equal to the bottom of this fraction. So in other words, I'm going to multiply by a fraction. This unit here has to go in the denominator, so it will cancel out. And what I put up above has to be equal to what I put down below via a conversion factor. So I'm getting rid of ounces. What I'm going to convert them into depends on what conversion factors I have access to. So I look here and say, well, the only thing I could convert ounces into in this case is pounds. So I'm going to have to put 1 pound up above and 16 ounces down below. All right? And the reason is that by doing this, ounces cancels out. I'm left with pounds. But this expression is really equal to 1. Since this value and this value are the same, I haven't changed the overall amount of matter that I'm talking about here. All right? That's why this works. It is essential that you understand two things. One, whatever unit you have here that you don't want must go in the denominator. So if I don't want pounds, it's going to have to go into the denominator in the next step. The other thing you must understand is the numerator and the denominator must be equal to each other via a conversion factor. All right, whether that's a given one or a measured one. So in this case, I want to get to grams. I don't want pounds. So where do I have to put pounds? I have to put it in the denominator. All right. Okay, so pounds has to go in the denominator. Now look, I've canceled out ounces. I've canceled out pounds. I've got kilograms. I don't want kilograms. So kilograms has to go into the denominator. And I can put grams above. And since I've memorized, like Mr. Simpson told me to, that 1,000 grams equals a kilogram, I'm good. Even though they didn't give me, well, they did give me that one, darn it, but they won't, okay? So now I have the unit I want on top in the numerator, and now I'm ready to go ahead and let the magic happen. All I have to do is multiply all the top numbers and then divide by all the bottom numbers. So 25 times 1 times 0.45 times 1,000 divided by 16, divided by 1, divided by 1. And I'll get my, well, there it is, and then I'll get my answer, okay? I have to make sure I write down the unit. That's all there is to it. And I'm sure you've done this in chemistry. And a lot of times people want to take shortcuts, and there's no credit given for shortcuts. And if you get the wrong answer, you get 0 credit. And a lot of times if you get the right answer, but you didn't show your dimensional analysis, you'll only get partial credit. So please get over yourself and show your work. All right. Now, the other thing I want to point out is a lot of times in APES, we're going to actually be given data with which we're going to construct a conversion factor. So look at this. Let's just say I take measurements in a lab, and here's what I find. Okay. Let's say we have a 12-meter patch of forest, and in it we do a count, and we come across 27 fern plants. Now, from this, we're asked to extrapolate. Well, if the forest overall has an area of 17 acres, how many fern plants are in this forest preserve? So the way I would do this is I want to make sure, first of all, that I never start with a conversion factor. The first thing you write down is not a conversion factor. It is a measurement that I now want to convert into another measurement. So in this case, what I have is I know I have 17 acres, and I want to turn acres into fern plants. That's what I've been asked to do. I want to turn 17 acres of forest preserve into a certain number of plants. So I'm going to start with 17 acres. Now I look at my conversion factors, and here they are all. All right. Now, I look up, I'm given that 1 acre equals 0.4 hectares, and I've been told that 1 hectare equals 10,000 square meters. This is a conversion factor that I had to measure on my own. In this experiment, we counted that 12 square meters had 27 fern plants. So we use that as a conversion factor. I'm going to start with acres. I don't want acres, so it has to go. I'm going to multiply by a fraction, and I'm going to put acres down below. And what can I put up above? I can put hectares up above, and here's why. I have a conversion factor that tells me 1 acre equals 0.4 hectares. And I have to make sure that I put the correct number with the correct unit. 1 goes with acre, and 0.4 goes with hectares. I don't want hectares, so I'm going to multiply by another fraction that has hectares in the bottom. What could I turn hectares into? I could turn it into square meters. Now, acres has been canceled out. Hectares has been, I have square meters, but I wasn't asked how many square meters were in 17 acres. I was asked how many fern plants. So now I've got to put square meters in the denominator, and I can convert that into fern plants. Now, once everything cancels out, I have ferns up above, which is what I've been asked to find. Okay, how many fern plants does it have is what I'm looking for. So now I'm just going to go ahead and multiply by all the top numbers, divide by all the bottom numbers, and what I get is 150,000 ferns. Guys, thanks for listening. Hopefully you'll have no problem doing this when we practice this in class tomorrow.